Unit 4, Section 11.1 Worked Examples. Several friends chartered a boat for a day's fishing. They caught a total of 57 fish. The table below provides information about the type and number of fish caught. Determine the empirical probability that the next fish caught is grouper. Enter the answer as a simplified fraction. To determine the empirical probability, we'll divide the number of grouper caught by the total number of fish that were caught. And we notice that there were 16 grouper caught, and we know there were a total of 57 fish caught. So the empirical probability is 16 over 57, and that is simplified. In a sample of 70,000 firstborn babies, 3 were found to have a certain syndrome. Find the empirical probability that a family's first child will be born with this syndrome. Enter the answer as a simplified fraction. To determine the empirical probability, we will divide the number of babies with the syndrome, which was 3, by the total number of firstborn babies in the sample, which was 70,000. And again, this fraction is simplified. The table below shows the 10 most popular destinations for college students from country X studying abroad for the 2008-2009 school year. If a student were selected at random from those who studied abroad in 2008 to 2009 at one of the destinations in the table, determine the empirical probability that the student studied in country E. So in country E, we look in the table and we see 12,486 students in that group. 12,486. And the total in the table is 149,855. And that fraction is simplified. And then for country B, we see there were 27,026 students. And we're going to divide by the total number of students in the table, which is 149. $855. A monk crossbred plants which can have purple or white flowers and obtained 769 plants with white flowers and 308 plants with purple flowers. Find the empirical probability that a plant had each type of flower. Enter the answers as decimals rounded to the nearest hundredth. First, we need the total number of plants. So we need to add 769 to 308. And I'm going to move my calculator over, and I'm going to go ahead and I'm going to add 769 plus 308. Oh. And I get 1,077. So that's going to become the denominator for each of my probabilities. 1077. And if I take my calculator again, and I take the 769, and I divide by the 1077, and it's sent around to the nearest hundred, so that would be 2 decimal places, so it's going to be 0.71. Now, in this section, I learned about complements, and I know that if it's not a white flower, it must be a purple flower. So I could do the division, but I can also subtract 0.79 from 1 to get 0.29. One card is selected at random from a deck of cards. Determine the probability that the card selected is not a queen. Enter the answer as a simplified fraction. The event not a queen is the complement of the event of selecting a queen. So let's determine the probability of selecting a queen. So in my deck, I have 52 cards, 4 queens, and the simplified fraction is going to be 1 over 13. So I can use the complement rule, which says the probability of a not queen is 1 minus the probability of a queen. So 1 minus 1 over 13 gives me 12 over 13. Assume the spinner cannot land on a line. Determine the probability that the spinner lands on red, green, yellow, and then not yellow. So when I look at the circle here, I see it's divided into 8 sections. So the probability of landing on any one of those sections is going to be 1 out of 8. So for red, I see that there are 3 regions, so the probability of red is going to be 3 out of 8. The probability of green, I see there's 4 regions, so 4 out of 8, but I need to simplify my fraction. So I'm going to get 1 over 2. The probability of yellow, I see there's only 1 yellow region, so this is going to be 1 out of 8. And then for the probability of not yellow, I can use that complement relationship and subtract 1 minus the probability of yellow. And so I get the probability of not yellow is going to be 7 over 8.